Hello everyone, welcome to Zero Labs. Yes, still here. No, I have not been shut down. Today is Thursday, September 10th, 2020. I'm Mark Brash, your host, and today I would like to talk about basic electronic troubleshooting, and more specifically, we're going to be troubleshooting a Pioneer receiver that I picked up on eBay for 20 bucks. I'm sorry, not on eBay, on Craigslist for 20 bucks. It is the VSX D710S Pioneer receiver. So of course I first did a little bit of research on Google and on YouTube to make sure that this topic hasn't been beaten to death already. I don't want to release content that is, a Me Too kind of video. But I think this merits a little bit of consideration. So we're going to go over basic troubleshooting skills. And again, as I said, specifically on this receiver. Now, I paid $20 on Craigslist. I got what I paid for. I hooked it up in my my home theater system. It worked for a little while. Then the right front channel started going intermittent. Okay, wow. Now there's a scary term in when you're trying to troubleshoot any kind of electronics. The intermittent failure. Intermittent failures fall into a number of categories, and we're going to go over those. If you can, always first see if you can find the technical service manual for the piece of equipment that you're working on. Now, I know for some of you this may look like a really scary document, but I'm going to go over some of the basics of being able to read a block diagram and identify components in a schematic diagram, and to basically follow the path through the circuitry from beginning to end and see if we can identify where along the chain we have a problem. So the first thing I do is I download whatever information I can find. If you can't find a service manual and you're sort of groping around in the dark, you can still troubleshoot electronics by groping around in the dark, but believe me, it's a lot easier if you've got the service manual in front of you. I almost always, when I search for a service manual, I will look up the model number of equipment that I'm working on, and I'll say schematic diagram in my Google search. And it will almost always pull up a service manual because the service manuals have the schematic diagram in them. And they almost always come up from manualslib.com. I'll post a link to that in the description, but Google will probably find it for you as well. manualslib.com. Great resource. I don't know if they accept donations, but I'm going to look, and if they do, I'm going to send them a few dollars because this is good stuff, and I've had very good luck with ManualsLib. So the first thing I did was I printed out and made a booklet of the pages that I felt were relevant. All right, I have the exploded view. The exploded view has a list of the part numbers, exploded view of the front panel, and probably the single most important page is the general block diagram. Now you see I've had to assemble this booklet into fold-out pages because the schematic diagram, when you're looking at the PDF, is all 8.5 by 11, but the pages flow from one page to another, and they really should have been formatted for a 11 by 17 page size legal document, or 11 by 14. No, 11 by 17. Yeah, but anyway, Pioneer did a really nice job in formatting their schematic diagrams, even though they're on separate 8.5 by 11 sheets, because right down the middle they left a lot of space where all of the lines cross from one page to the next, so that you can easily take a pair of scissors on your kitchen table, cut the pages to line up and tape them together so that you can create this little fold out. Really handy to have. I like to make it into a booklet because it's nice to have. This is the basic connector assembly diagram. It shows how all of the boards inside the receiver interconnect. And then we get into the schematic diagram. All right, I printed out the pages that I believe are relevant. So let's talk about how I went about troubleshooting, at least to the stage that I'm at right now. Okay, number one, does it turn on? Sorry to sound like a Dell tech support technician, but yeah, it turns on. Okay, everything operates. The FM tuner operates. I can select all of my inputs. But the basic problem is my right front speaker is intermittent. So I want to know, I want to at least make a reasonable guess where I should start looking inside this box for the problem. So you need to logically think about how the signal is processed. Fortunately, audio equipment is fairly simple. You have an input, you have a whole bunch of switching and amplifier stages, a low-level input, and then you have a high-level output, which goes to the speakers. Logically, the quickest way, I think, to diagnose it is to work backwards from the speakers. So the first thing I did was to make sure that my speaker was good, and I popped it with a 1.5-volt battery on the speaker terminals to make sure that the speaker on the wall was working properly, and it was. I then put the receiver through all of its paces, and I checked all of my inputs. And the problem is, you know, you have to catch it. It's an intermittent failure. You have to catch it while it's failing. When it was failing, I switched from my CDR inputs to my TV satellite inputs to my DVD inputs to my FM tuner inputs. And I found that all of those inputs produced the same problem. The right front speaker still wasn't working. So right there, I know that I can exclude literally half of all of the schematic diagram from the block diagram. Here's the whole block diagram. I can exclude this whole half right here, because this is all input circuitry. This is where all the preamplification is, where all the digital decoding is done, where the tone control is, etc., etc. And since all of these did the same thing, I know that the problem is someplace further down the audio chain. And they do it real nicely. They even show you with little arrows on bold lines where the audio path travels as you follow the path all the way through the amplifiers to the speakers. After further referring to my block diagram, I noticed that there was an amplifier stage that went to the headphone output jack. And that little amplifier stage, if you follow the signal path, was after the preamplifier for the right front speakers. So the next step in my diagnosis was to plug the headphones in. And guess what? The right earpiece was working. That tells me I can also eliminate all of the preamplifier circuitry as being part of the problem. The only thing left is this interconnect board that senses audio lines and does some muting and some things like that, and then it passes the audio to the main amplifier board. So this is where I'm going to be concentrating my search right now, is the main amplifier board. And true to form, after connecting my two speakers to the receiver and turning it on and putting the FM tuner on, I had hiss from both speakers, because this is an intermittent problem. Generally, I kind of cringe at that, but fortunately, after I connected my signal generator, which is right up here, and set it to 1,000 hertz at a minimal input level, and a splitter to one of my auxiliary inputs on the amplifier, switched to the aux input, and the right speaker was not playing. When I went back to the FM tuner, it again also was still not playing. So my initial diagnosis of being able to exclude all of the preamp sections and before still holds true. Now, what I'm going to be doing is I'm going to be taking and dismantling this case as carefully as I can without disturbing physically the components inside, because I want to catch it in the act. I want to be able to jiggle something and have the audio cut in and out. So that's the plan. I don't know if it's going to work, but we're going to see. Here we go. I'm connected to my aux input with a Y splitter, so I have a monophonic signal going into both jacks, and that's my audio signal. It is only coming out of this speaker that's over here, that's off camera, that you can't see right now, but not this speaker here. If I plug headphones into this jack, it will come out of both speakers, both earpieces, so I know where the signal is getting through and where it is not getting through. So we don't have to keep listening to that. I am going to leave it turned on and hope that it continues to stay in failure mode, and take off the retaining screws that hold the cover in place. Actually, I'm going to leave the signal on just in case I should accidentally happen to touch or jar something that causes it to start working again. I'll want to know about it right away. Ooh, dusty. Wow. Not good. My interconnect cables come across over here. So, referring back to the mechanical assembly drawing, which is the first drawing that I saved, I know where these parts are physically located inside the cabinet. I know that this is the main amplifier board right here. I know that this is the preamplifier board running along the edge on this side of the receiver, and my little daughter board is right here at the front, plugged into this connector on the main board. So now I'm going to start jiggling things and see if I can't make some magic here. Okay, it didn't like that. Now if I was a betting man, my bet would have been on a bad solder joint on this main hybrid amplifier module right here, mounted to the heatsink. But such is not the case, because I'm moving the whole assembly back and forth and I'm not getting any cutout from there. Alright, this is going to require a little bit further diagnosis. I hope it's not the module, that's all I can say, because that would suck. Okay, at this point I'm going to go back to my block diagram. Here's my speaker output from the main power pack, and they only show one speaker, but this is assumed to be stereo, and I'm looking at where this audio path needs to travel, and it has to pass through relay 751. Okay, that should do it for that. Apologize for all the noise. Now I can actually read the lettering on the top of the PC board, however, and identify where these relays are. For the right front speaker, I am looking for L751. Inside the chassis, we have our front left and front right amplifier block. There's 2 channels in this amplifier block. This amplifier block is physically a little larger. It has 3 channels in it. It has the surround left, surround right, and center channels in it. None of those are malfunctioning. And then these 5 coils are all in series with each channel of the speaker outputs. So if I find an audio signal on one of these here that will be L751 according to the schematic diagram, once I find it, if I've got a signal on this coil, that would be on the near side of the relay, but I have nothing at the speaker terminal, that would indicate a bad relay. Those do go bad, and we'll see what that looks like. Then I'll just continue to work my way back through the schematic diagram until I end up finding where the signal is being lost. And of course I have output now. Of course, why would I not have output from the channel that failed? Now I have to try and make it fail again. Awesome. There. Wow. Just switching the speakers. Uh-huh. Getting close, folks. And if it is the relay, A, I might have another relay, believe it or not, and B, even if I don't, I'll probably end up taking the main amplifier board out of the chassis and remove the relay and try to actually rebuild the relay itself and burnish the contacts. I've done that as well. Starting to come back all by itself. Wow. Crap. Not what I wanted. See what I mean about intermittent problems? Damn. Bingo! Ah! Check this out. It is a bad solder connection because, watch, I'm not going to bang on the relay. I'm just going to give it a little push. There it is, folks. Bad solder connection on the relay, on the speaker switching relay. So yeah, I will take the whole amplifier board out now, and I will probably do a lot of touching up on what may even look like marginal solder connections underneath. Actually, it could still be a bad relay, because by pushing on the casing of the relay, I'm pulling on the terminals in the relay, which could be making and breaking the contact. That's an unknown right now. What is a known is it's that relay. So through a little prodding, I was able to locate the source of the signal path loss, and it was, according to my schematic diagram, relay 751, R751, which is the speaker switching relay for the front right speaker, possibly even the front left, I'm not sure. Yes, it is for front right and front left, but one of the contacts is bad, or there's a bad solder connection on the PC board where the terminals go through. I've referred to this page in the service manual, which describes exactly where all the screws are that need to be removed, so that I can take this entire assembly and lift it out as one piece to get a look at the bottom of the PC board. I may wish to, yeah, I think I'm going to pull these interconnect boards off of the transformer as well, rather than try to lift the transformer out with the PC board, because it's just going to get in the way. Here we go. Last 3 screws, and I should be able to take the whole main board assembly out of the chassis, not including the front panel assembly, which I've disconnected. One little bracket doesn't want to release here. There we go. Yes, there it is. There's the circuit board. Now I can get to work on checking the solder connections, and if those are good, then I have to look at refurbishing or replacing the relay. I've gone ahead and disconnected the main amplifier board now from the back panel of the chassis. This will give me full access to the back of the PC board, where I can desolder the relay that's causing me a problem. It is this relay right here, R751, R standing for relay, not resistor. It might be RY751. I think that's what it is. So I'll set the back panel aside now, and we'll reassemble this later. Here is the front right audio path, right here. It comes into this inductor, which is L751. The other side of L751 is right here. These 2 terminals here are the coil. This is the normally open relay for the front right. This is the normally open relay for the front left. And look real close at that solder connection, and you can see a crack around the edge of that solder connection. That was a failure just waiting to happen. I'm going to give that a very high probability of being the cause. There's a good shot of it right there. I'm giving that a high probability of being the cause of my problem right there. Alright, so I've gone ahead and put the chassis back together. I resoldered the connection that I found that was cracked on the PC board. And let's test the receiver now. There's both channels. There's the right channel only. my FM radio. So the repair is a success. Thanks all for joining me. I hope you had a lot of fun watching this troubleshooting video and how I go about troubleshooting an audio component. The same principles would apply even if I was going to troubleshoot a piece of digital equipment. You've got some place where a signal goes in, you've got some place where a signal comes out, and if the signal is interrupted someplace in between, it's not going to make it to the very end. My original hypothesis that it was a bad connection induced by a bad solder joint was correct. I'm glad it wasn't a component that needed to be replaced, because I may or may not have had that in my spare parts.